Hello friends, welcome to ChemFinder. Today we will discuss about some stereospecific reactions. In a stereospecific reaction, what will happen? Formation of only one stereoisomer. For example, you see the stereoisomer of A and C forms B and D stereoisomer respectively in the reactions. So we can consider this reaction is stereospecific reaction. This stereospecific reaction also a stereoselective reaction because A forms selectively B, C forms selectively D, and A is not forming D, C is not forming B stereoisomer. Okay, hence the stereospecific reaction we can consider as stereoselective reaction also. In stereoselective reaction, what will happen? Formation of only one product as major, the other one will be the minor. For example, you see A forms B and C stereoisomers, but B forms more than C, so we can consider this reaction is a stereoselective reaction. We can say all stereospecific reactions are stereoselective reaction, but all stereoselective reactions are not stereospecific reaction. In stereospecific reaction, what will happen? The stereochemistry of reactant will decide the stereochemistry of product. But in stereoselective reaction, the reaction will have choice of pathway. Among the choice of pathways, the more favorable pathways will form the major product, the less favorable pathway form the minor products. So this is a stereoselective reaction. Now we will see some stereospecific reactions. The first reaction is electrophilic addition of bromine to the maleic acid. Here the maleic acid reacts with the bromine molecule to form the corresponding brominium ion. Now the bromide ion can attack A carbon as well as on B carbon also. When attack happens on A carbon, the corresponding stereoisomer forms for 50% which is having S and S configuration. When attack happens on the B carbon, the corresponding stereoisomer is forming which is having R and R configuration. Now you see both are enantiomer only and racemic product is forming from this reaction. We can say this reaction is stereospecific reaction because the stereochemistry of maleic acid is cis, which means the functional group of acid are cis to each other. The same stereochemical outcome retained in the product also. Here also the acid groups are cis to each other. So we can say this reaction is stereospecific reaction, and also we can say this reaction is stereoselective reaction because in this reaction two chiral center is forming. According to 2n formula, we will have the 4 stereoisomers, but out of 4 selectively 2 only is forming. So we can say this reaction is stereoselective reaction also. Similarly, when fumaric acid reacts with the bromine molecule, it forms the corresponding brominium ion. Here also the bromide ion can attack on the A carbon as well as on the B carbon. When attack happens on A carbon, the corresponding product is forming which is having R and S configuration. When attack happens on the B carbon, the corresponding product is having R and S configuration. Now you see both are identical product only because configurations are same only. When I write the Fisher projection for this staggered conformer, we are having a planar symmetry in this Fisher projection. We suggest that this molecule is meso and aptically inactive. Hence, from this reaction, only one product is forming, that is meso. And you see the stereochemistry of this fumaric acids is trans, means the acids are trans to each other. In the product also the acid groups are trans to each other, which means the reaction is stereospecific. And this reaction is stereoselective also because you see we are having 2 chiral center in the reaction in the product, which means we will have 4 stereoisomer according to 2n formula. Out of 4 stereoisomer, only one stereoisomer forms selectively. Hence this reaction is stereoselective reaction also. Here I have given another electrophilic bromine addition reaction with the trans-butene and cis-butene. As we discussed the electrophilic bromine addition with the fumaric and maleic acid, this reaction also is stereospecific and stereoselective reaction. Now we will discuss about epoxidation reaction with alkene. When cis stilbene molecule reacting with the m-CPBA, it forms the corresponding epoxide products. When m-CPBA approaches the top face of the alkene, we are having this stereoisomer. When m-CPBA approaches bottom face of the alkene, we are having the this stereoisomer. This stereoisomer having R and S configuration. This stereoisomer having S and R configuration. Now you see both are having identical configuration only. Hence we can say these two products are identical product. And you see there is a plane of symmetry in this molecule which suggests that this molecule is a meso compound and aptically inactive. Similarly, when trans stilbene molecule reacting with the m-CPBA forming the corresponding two stereoisomers which are enantiomers and forming 50% and 50%, that is racemic product. When m-CPBA approaches top face of the alkene, this stereoisomer is forming. When m-CPBA approaches bottom face of the alkene, this stereoisomer is forming. These two reactions are stereospecific reaction only because the stereochemistry of these stilbene molecules is retained in the products, as well as this reaction is stereoselective reaction also because out of 4 stereoisomer we are having selectively one stereoisomer and two stereoisomer here. Hence this reaction is stereoselective reaction also. Now we will see the epoxide hydrolysis reaction. When this cis epoxide reacting with the protonated acid in presence of water, it forms the corresponding protonated intermediate which react with the water nucleophile to form the corresponding product. When water nucleophile attacks on the A carbon, this stereoisomer is forming, which is having S and S configuration. When water nucleophile attacks on the B carbon, this stereoisomer is forming for 50% and having R and R configuration. Now both the stereoisomer are enantiomer and racemic product. This reaction is stereospecific reaction because the stereochemical outcome of this epoxide is retained in the product. Hence this reaction is stereospecific, and this reaction is stereoselective also because out of 4 stereoisomer according to 2N formula we are having selectively two stereoisomer. So this reaction is stereoselective reaction also. Now we will see the hydrolysis of trans epoxide in presence of Lewis protonated acid and water. The trans epoxide forms the corresponding protonated intermediate. Now the water nucleophile can attack on the A carbon as well as on the B carbon. When attack happens on A carbon, this stereoisomer is forming, that is having S and R configuration. When attack happens on B carbon, this stereoisomer is forming, which is having R and S configuration. Now you see configuration of these two chiral center are same only, hence these two products are identical product, and there is a plane of symmetry passes in this molecule, and hence this plane of symmetry suggests that this molecule is meso and aptically inactive molecule. And you see the stereochemical outcome of this trans epoxide is retained here because we are having the trans product only, and this reaction is stereospecific. This reaction is also stereoselective reaction because out of 4 stereoisomer with 2 chiral center we are having only one stereoisomer selectively. Hence this reaction is stereoselective reaction also. Previously we saw the epoxide hydrolysis of trans epoxide with R and R configuration. Now I have given the corresponding enantiomer that is having S and S configuration. This epoxide also will give the meso product only under hydrolysis condition. Hence this reaction is stereospecific as well as stereoselective reaction. Here I have given the overall conclusion of epoxidation of alkene and hydrolysis reaction. The cis alkene reacting with the m-CPBA and forming the meso epoxide which is aptically inactive. This epoxide reacting with the acid in presence of water and forming the corresponding racemic product. When trans alkene molecule reacting with the m-CPBA, we are having the product that is racemic. In presence of this acid and water, the racemic epoxide gives the corresponding meso. Both the reaction is stereospecific and stereoselective. Now we will discuss about elimination reaction. This stereoisomer having S and S configuration reacting with the sodium ethoxide base and forming the corresponding Z alkene. This base takes this beta hydrogen and remove the alpha bromine and gives this alkene. Okay. Here I have given the Fischer projection of this stereoisomer. Here hydrogen and hydrogen are in the same direction, hence this is erythro stereoisomer. Now we have to convert this Fischer projection into the Newman projection for the elimination reaction. At first I have taken this carbon in front of the Newman ring and I have taken this carbon backside to the Newman ring. When you write the second carbon, you have to interchange the groups. So I have taken the right side hydrogen to the left side. In the left side hydrogen I have taken in the right side of the Fischer Newman projection. The right side bromine I have taken in the left side in the Newman projection. So this interchange we have to do. Now we don't have the corresponding anti-periplanarity for the elimination. To remove the hydrogen and bromine from this molecule in presence of base, we need anti-periplanar state. Hence, to get the anti-periplanar state, I am rotating this front carbon for 120 degree and having this Newman projection. Here you see the molecule having anti-periplanar state. Now the base takes this beta hydrogen and removing the bromine gives the corresponding alkene. Now you see both the phenyl group are in the cis direction. So I have drawn the molecule like this with the cis direction of phenyl group. This reaction is stereospecific reaction because you see the erythroisomer giving the Z alkene. To confirm this reaction is stereospecific or stereoselective, we need to compare the reaction with the triisomer. If you compare the reaction with the triisomer, you will have the E product here. If you take the triisomer, now we will see in the next slide. In the previous slide, we saw the elimination reaction with the erythroisomer. The erythroisomer gave the corresponding Z alkene specifically, so that reaction is stereospecific. Now we will discuss about the triisomer. The triisomer having R and S configuration. When triisomer reacting with base, we are having the alkene that is having E geometry. Okay. Here I have given the Fischer projection and we have to convert the Fischer into the Newman projection. I have taken the Newman projection here. As I told previously, we have to interchange the groups here. The first carbon I have taken in front of the Newman ring. When I am writing the second carbon, I am interchanging this bromine and hydrogen from left to right, right to left. Okay, now you see the Newman projection already having the anti-periplanar state. So the base remove this beta hydrogen and forming this alkene. Here you see both the phenyl are anti to each other. So I have drawn like this with the anti-phenyl groups. This reaction is stereospecific reaction and also stereoselective reaction because erythroisomer specifically gave Z isomer, triisomer specifically giving E isomer. Both are giving selectively different product, and this reaction is stereoselective reaction. The next reaction is SN2 reaction. You see this S stereoisomer reacting with this nucleophilic reagent in DMF solvent to give the corresponding R stereoisomer. When R stereoisomer reacts under the same condition to give the corresponding S stereoisomer, we all know in SN2 reaction we will have the inversion product. Okay, this reaction is stereospecific reaction because the S stereoisomer is deciding the configuration of the product and R stereoisomer deciding the configuration of the product. And also this reaction is stereoselective reaction because S gives selectively R and R gives selectively S. S is not giving S stereoisomer product, R is not giving or stereoisomer product. Hence this reaction is stereoselective reaction. We will see hydrogenation reaction. Here I have given a cis alkene. It reacts with the hydrogen in presence of palladium in carbon and gives the corresponding product. When hydrogen molecule approach backside of the alkene, we having this stereoisomer having R and S configuration. Sorry, this stereoisomer. When hydrogen approach in front of the alkane, we are having this stereoisomer having R and S configuration, because when hydrogen comes in front of the alkene, this 2 deuterium will go backside. When hydrogen approach backside, the hydrogen will be on the backside and deuterium will come front side. I have taken this 2 methyl with solid bond. You can take deuterium also, and you see both the product are same only because configuration is same. I have given the Fischer projection here, which is having a planar symmetry, which conclude this molecule is meso and aptically inactive. This reaction is stereospecific because the stereochemical outcome is retained from the starting material, and also this reaction is stereoselective because we are having only one stereoisomer out of 4 stereoisomer. Here I have given the corresponding trans alkene. When hydrogen approaches backside of the alkene, we will have the methyl and deuterium in front and hydrogen will be at the backside. When hydrogen molecule approach in front of the alkene, the methyl group and deuterium will go backside and hydrogen will be in front of the display. Okay, now both the product forms are 50% and they are enantiomer. So from this reaction we are getting the racemic product. This reaction is stereospecific reaction because the stereochemical outcome of this 2 methyl group is retained in the products, and also this reaction is stereoselective because with 2 chiral center, according to 2n formula, we will have 4 stereoisomer. Out of 4, only 2 stereoisomer formed selectively. Hence this reaction is stereoselective reaction. The next reaction is hydroboration reaction. We all know the hydroboration reaction. Hydroboration addition of 2 alkene will give the corresponding alcohol. This addition, hydrogen and boron addition, is a syn addition, and this reaction occurs according to anti-Markovnikov rule. So the boron will be added to the less substituted carbon. When the boron molecule reacting with the peroxide acid in presence of base, we will have the corresponding alcohol. Here we are having the 2 alcohol which are formed for 50%, which 50%. Hence from the reaction we are getting the racemic product. You see the stereochemical outcome of the alkene is retained in the product, means the methyl group and this hydrogen are cis in this molecule. Here also we are having cis direction. So this reaction is stereospecific and also stereoselective because out of 4 stereoisomers we are having only 2 stereoisomers selectively. The next reaction is cyclopropanation reaction. This reaction is Simmons-Smith reaction. This trans alkene molecule reacting with methylene chloride in presence of zinc, copper and in ether solvent to give the corresponding 2 stereoisomers that are racemic. Actually what happens, this methylene iodide reacting with zinc copper and forming the iodomethyl zinc iodide, which called as carbonate. This reaction goes via concerted reaction mechanism, not stepwise reaction mechanism. When this reactive species approaching the alkene on the top face of the alkene, you will have this stereoisomer. When approach occurs on the bottom face of the alkene, you will have corresponding stereoisomer for 50%. Now you see the stereochemical outcome of the alkene is retained in the products. Hence this reaction is stereospecific. According to 2N formula with the 2 chiral center, we will have the formation of 4 stereoisomer in the reaction, but we are having selectively 2, so this reaction is also a stereospecific reaction. The next reaction also same with the cis alkene molecule. The cis alkene molecule under the same reaction condition give the corresponding products. Here the product is meso because we are seeing there is a plane of symmetry in the molecules and this molecule is artically inactive. This reaction also stereospecific because stereochemical outcome is retained, and stereoselective because we are having only one stereoisomer out of 4. This reaction also is another type of cyclopropanation reaction with the chloroform and potassium tetraprotide oxide. This combination you might have seen in the Reimer-Tiemer reaction. Here what happened, the trans alkene molecule reacting with this chloroform in presence of base and forming the corresponding enantiomers that are racemic. This reaction is stereospecific as well as stereoselective as we discussed in the previous slide. When cis alkene reacting under the same condition, the corresponding cyclopropanated compound is forming, which is having a planar symmetry. This planar symmetry says the molecule is meso and haptically inactive. This reaction also is stereospecific and also stereoselective reaction. Here I have given the mechanism. When base reacting with the chloroform, the alpha protons is removed and forming the corresponding anion. From this anion, alpha elimination of chloride takes place to give the corresponding carbene. The carbene is singlet carbene because you see the electrons are anti-parallel each other in this chloroform molecules. Why we are saying singlet? Because according to spin multiplicity formula, that is 2s plus 1, if you substitute the spin value that is 0, you will have the value 1 that says the carbene is singlet. This reaction also is a concerted reaction. When the carbene molecule reacting with this alkene, you will have the corresponding product. Here the carbene acts as both electrophile as well as nucleophile. The next reaction is Diels-Alder reaction. Here I have given the butadiene molecule. When butadiene molecule reacting with this dienophile under thermal condition gives this compound. This compound is meso compound and haptically inactive. You see the stereochemical outcome of this dienophile is retained here. So this reaction is stereospecific and also stereoselective because we are having only one stereoisomer out of 4. Similarly, the same butadiene molecule, sorry, I have given the cis dienophile instead of giving trans dienophile. When this dienophile diene reacting with the trans dienophile under thermal condition, you will have the corresponding pair of enantiomer, that is racemic. Okay, this reaction gives only 2 stereoisomer out of 4 stereoisomer. So this reaction is stereoselective and also stereospecific because you see the stereochemical outcome of the trans dienophile is retained in the product. And this session I forgot to give you one more stereospecific and selective reaction, that is reaction of alkene with the osmium tetroxide. When you react the alkene with the osmium tetroxide, we will have the corresponding diol. This reaction is concerted reaction. The diol will be cis to each other only. So this reaction is stereospecific only for, means if you take the cis molecule, you will have the cis diol. If you take the trans molecule, you will have the trans diol. So our stereochemical outcome will be retained in the product. Hence this reaction is stereospecific and also stereoselective because selectively trans and cis alkene will give the corresponding products. Thank you.